All right, now for this example, we might need to think about our angles in kind of a different way. Now, we looked at earlier the angles being part of a circle. Now, in this case, and what you'll be thinking about a lot of times in examples that come, if you have an XY axis, um, angles typically start on the positive x-axis and they end or terminate depending on how large theta is. So let's look at the example 80 degrees. Of course, from the x all the way up to the y would be 90 degrees. So 80 degrees is going to fall somewhere, probably a little bit more than that, uh, somewhere close to 90, but not quite 90. So something like this perhaps might be 80 degrees. So we're talking about this angle between the positive x-axis and the line I drew. It would be 80 degrees. So again, this is where the angle terminates, so to speak. So when I say identify all angles that are coterminal, that means what other angles terminate at the same spot 80 degrees does. And there are infinite numbers of possibilities that do. As you can see, if I were to keep going, I'd hit 90. When I get here, I have a straight line from the right part of the x-axis to the left part. That's going to give me 180. Down here to the negative y-axis gives me 270. And when I complete my circle, I get 360. So as you can imagine, if I take 80 and I then add another 360 degrees to it, I'm going to get 440 degrees. So 440 is an angle that's coterminal. And of course, I could add another 360 to that and get 800 degrees. Or I could go the other way. I could start at this axis and go in a negative clockwise direction, and I don't quite make a full circle, but since I went in the reverse direction, that's going to be a negative angle, and it's going to be 360 take away 80, so essentially negative, negative 280 degrees. So those are two angles that are coterminal with 80, and the way we can figure out all the angles that are coterminal would be if we took the degree measure 80 degrees and then said plus or minus 360 times some number we can call n. Because 80 plus 360 we saw was 440. If we doubled 360, we could get that degree measure of 800 and so on and so forth. So this gives me every angle that's coterminal with 80 degrees. Now for our second part, we're doing the same thing only with radians. So in this case, we have pi over 4 radians. Now remember, in a full circle, just like you have 360 degrees, you also have 2 pi radians. So that means in a half a circle, so from one side of the line to the other, you're going to have pi radians, which means your 90-degree mark is going to be pi over 2, a half a pi radians. So pi over 4 is essentially 45 degrees. But since we're negative, we're going to take it this direction, and it's going to be negative 45 degrees, or negative pi over 4. So this is what negative pi over 4 would look like as an angle. We want to find everything coterminal with it. So we can't just add pi every time, because if I add pi, I'm going to end up somewhere out here 180 degrees away. We need to add 2 pi to get the full circle. So we would take negative 5 over 4 plus or minus 2 pi times some number. But I'm just going to put the number in between the 2 and the pi. So I guess you could write 2 pi. I actually kind of like 2 pi n better. The book goes 2n pi, but 2 pi n makes more sense to me because it correlates with the 360n that we used before. So same idea. And then 2 examples of that. You could have negative pi over 4 plus 2 pi, which is essentially negative pi over 4 plus 8 pi over 4, which would be 7 pi over 4. Or you could have negative pi over 4 minus 2 pi, and that will give you negative pi over 4 minus 8 pi over 4, or negative 9 pi over 4. And 7 pi over 4 would look something like this if we drew it. It would be a full 2 pi around this way. And negative 9 pi over 4 would be if I started here and went around once fully and then came back again and drew an angle there. So that's how you would draw your coterminal angles. You just keep going around and around. So go ahead and see if you can determine 2 angles that would also be coterminal with 126 degrees.